Hello everyone, you are welcome to today's lesson. Today's lesson is going to be the continuation of lesson 1 and it's going to be lesson 2, so the continuation of lesson 1 on the topic the global mass or the earth as a sphere. In lesson 1 we looked at the definition of great circles and small circles, latitudes and longitudes. Okay, we look at some special latitude as well as what longitude. Only that I ask you to go and read on them. All right, you have those. I mean the notes, that information in your notes, I should say. All right, and we also looked at how to locate points on the Earth's surface. Okay, how to locate points on the Earth's surface. We also looked at the definition of, or how to find, I should say, how to find the circumference of a great circle and that of what? Of a small circle. We also learned about the connection between the radius of what? Of a great circle and that of what? The small circle. That's the relationship between a small circle radius and a big circle what? Radius. Okay, so in today's meeting, we are going to put on our previous concept, what we learned in lesson 1 to be dealing with typical global math questions, as you were made aware at the tail end of what lesson 1. So quickly, let me take you to the slide. Okay, so I'm going to skip up to where, so I think we got to how to find, we did all this in lesson 1. Hey, so we are going to look at, in today's lesson, we'll be looking at how to find the difference in angles between 2 points, and how to find the distance between 2 points on the Earth's surface. So basically, how to do this. Only that we're looking at another special distance, which will be the shortest distance between 2 points on the Earth's surface. So please stick and stay with me. I'm your usual Mr. Hackman. And please, you know the number 1 rule, don't hesitate to ask questions where need be. All right, so quickly, forgive me, let's look at what we have here. Finding the difference in angle between 2 points, and we are talking about 2 points on the Earth's surface. Okay, so this is it. So to find the difference in angle between 2 points on the Earth's surface, the following steps are followed. So step 1, we use the latitude angles to determine the difference in angles between the points if the points have a common longitude. So it means if the point that you'll be given is either they will have a common longitude or a common latitude. So if your points, they have a common longitude, then we will use the latitude rather to determine the angle of difference. Okay, in the same way, if your points, they have a common latitude, the 2 points, they have a common latitude, then we will rather use the longitude to determine the difference in angle, and that is catered for in the B. Use the longitude angle to determine the difference in angle between the points if the points have a common latitude. So it means common latitude, we use the longitude to determine. Common longitude, we use the latitude to determine. Is my point well made?
Yes.
Okay, now let's see. So step 2, if the 2 latitude or longitude have the same direction. So in this case, assuming maybe the longitude or latitude that you are now, I'm zooming into the longitude or latitude that we will use in finding the difference in angles. So if let's say your 2 points, they have a common latitude and you are using the longitude, okay, you know that the longitude will be measured east and west. Okay, so if your 2 longitude that you are using, okay, to determine the difference in angle, if they are in the same direction, maybe east, east, west, west. So the first point, its longitude is to the direction of the east. Okay, the second one to its longitude is in the direction of what? Of east. Okay, or west, what? West. Okay, however, again, so the north here, south here, it means this time round, you are rather talking about your latitude. So if your latitude that you are using to determine the difference in angle, if they are in the same direction, not north, south, south, this is how we determine. So the difference in angle between them is determined by subtracting the smaller angle from the bigger angle. So if it is north, north, south, south, east, east, west, west, the difference in angle, we get it by subtracting the smaller angle from what? The bigger angle. So the longitude with the bigger angle, you subtract what? The smaller angle, okay, from that. That is the longitude with the smaller angle, you subtract it from the longitude with a bigger angle. If you are talking about the latitude, you are using the latitude and they are in the same direction, you subtract the smaller latitude angle from the bigger latitude angle. However, if the two longitude or latitude that you are using to determine your difference in angle, if they are in opposite direction, meaning if one is north and one is south, so in this case I'm talking about latitude. If one is north, one is south, okay, if I'm talking about longitude, then one will be east, one will be west. If you have this situation, this is how we find our difference in angle. We are supposed to add. We are supposed to add. So the same direction we subtract. Okay, different direction we add to get what? The difference in angle. So by that, this is what I mean. Okay, I'm going to deal with, forgive me, I'm going to deal with specifics. Okay, so let's look at this question before us. It's very, very easy. Just know the basic information that I've given you. Okay, so if you have a common longitude, we use the latitude. But the latitude could be in the same direction or opposite direction. If they are in the same direction, we said, what do? We subtract the smaller angle, okay, from the bigger angle, okay, between the two latitude that you are using. Take note, if they are in the opposite direction, we add what? The two angles, as simple as that. So this is it. Okay, so this time round, I have drawn my X and Y. I don't want, okay, us to waste time drawing it as we did, but you are supposed to draw. So let's see. Find the angle between the latitudes of the following. So let's see. So solution, question 1. You extract what you are given. So given, let me see if I can go down a letter. Okay, give me some few seconds. Okay, I think you will still see it. So let me bring this one down. Okay, so this one should come down a little, and this one, I think this is where, okay, all right, okay, so this should rather go. Okay, when I need to clear it, I'll go and clear it because I don't think I will need it anyway. So let's go and look at, okay, what we were supposed to do. So in this case, you extract. So A, what are we giving? You've been given the points A with the latitude being 20 degrees, okay, south, okay, and what, 15 degrees, what, west. Now, if you end our second point, okay, we have A, okay, with 76 degrees, okay, south, okay, and 15 degrees, what, west. So if you look at these 2 points, okay, at the normal circumstance you mature, this diagram will not be necessary. You can determine the difference in angle straight away. Okay, now let's see. If you look at the 2 points, okay, what do they share or have in common? Is it latitude or longitude? The whole class. Look at the 2 points carefully. What did they have in common? Did they have a common longitude, which is 15 degrees west? Is that not it? So once they have, okay, the same longitude, and it means which, okay, should I say imaginary line are we supposed to use to determine the difference in angle, the latitude or the longitude? Per what you've been told. If they have the same longitude, what do we use?
We subtract.
No, we have to determine what we are supposed before we come and deal with the subtraction or addition. If they have the same longitude, we have to use the latitude. Look at what we have here. Use the latitude angles to determine the difference in angle between the points, if the points have a common longitude. So if they have a common longitude, we use the latitude. If they have a common latitude, we use the longitude. Is that clear? As simple as that. Okay, so you don't use the one that's okay are common. You don't use the ones that are common. You use the other one. Okay, so take to have that in mind. So this is it. I'm going to draw. Okay, but I said as you mature, you can. The drawing will not be, or the sketch will not be necessary. So you will draw your circle, which I'm assuming I have drawn. Then you indicate. Remember, I told you you have to indicate your north, south, and what your east, west, or west, east. So this will be your north pole, your south pole, then your west, what your east. But you know that this is 0 degrees, which is the equator. Okay, so east. So this is what we have. So if I'm supposed to fix this point, how do I fix this point? This point will be 20, so the latitude will be 20 south. So south is here. So I will come down and indicate my 20. So that is a latitude. So it's supposed to be okay, either north of the equator or south of the equator. But here we are told that it's being measured south of the equator. So this is what the 20 degrees south. My professors, I hope you are following latitude. And the longitude of A is 15 degrees west. So 15 degrees west, west is this, so of the meridian. So that one we are going to, okay, so this is 15. Okay, and that gives us what? So this is the 15, okay, degrees west. Okay, then this is where the point A will be. Do you agree? Where the latitude and the longitude meet, that's
Yes,
where the point A will be. Okay, what we did in lesson one. Now let's go and continue. Okay, this one, please, I think I have to do the correction quickly because it cannot be A. It's supposed to be A and B. Other than that, you are dealing with the same point, which shouldn't be. I hope you get my point. The point should be distinct. My professors, are you with me?
yes,
Okay, so let me quickly do the change. Then we move on to our presentation view. Okay, so that has been done. Okay, so now we are going to locate the point B. B, we are told 76 degrees south. So this is 20, so 76 will come down. Remember, the more you move away from the zero, the bigger your angle. So I will come down. So this will be my 76. Okay, it's also south. So I will come down here, 76 degrees towards south. So this is my 76 degrees towards south. Okay, and the 15 degrees west is already drawn. So where they meet, that is where your second point B is supposed to be located. My professors, are you with me?
yes, please.
Okay, so
Yes,
at the normal
please.
circumstance, okay, each of the measurements will be taken from the origin. So it will be the lines that you are going to form will be from here to here and from here to here. So you are finding the angle between these two lines. Okay, so that will be the angle between the 2 points. Take note, angles are formed between two lines. So we'll be using lines instead of, okay, so this is what we have. So now let's go and look at what the difference in angle. Okay, I think this should be for the B instead. So now let's go. So difference in angle. So this is what we are going to write. Therefore, difference in angle. So I'm going to write this. Okay, and I'm using this for angle. It's universally accepted. Will be equal to, remember we said once the longitude are the same, we have to use the latitude to determine the difference in angle. But the latitude that we are using, we have to consider the direction. Is the direction that will tell us whether we are supposed to add to find the difference or subtract to find the difference. But if you look at the latitude, okay, this is south, this is also south. So we said when the latitude are in the same direction, do we add or subtract? Same direction, what do we do?
Subtract.
We subtract,
Subtract.
but we subtract. We know angles cannot be negative. So we subtract the smaller one from the bigger one so that we end up getting a positive angle. So in this case, what are we going to do? The bigger angle, okay, or latitude is 76 degrees. The smaller one is, so that is going to give us 76, okay, degrees minus what? 20 degrees, which in effect will give us, okay, what? 56 degrees. My professors, are you with me? 56 degrees, right? Hello, are you there, my professors?
Yes, please.
Okay,
Yes,
so
please.
please
Citizen.
respond because sometimes network issues. Okay, so you know that so there is we are trying to say that the angle here, this angle that we have here, okay, will be what 56 what degree. That's the angle between these two what points. Okay, so on the same, okay, this is what I'm going to do, but I think I should have copied this one then pasted so that I won't draw the lines. Okay, so we are going to do same for B. Okay, however, this time around I'm not going to draw. Okay, so indirectly, so let's look at how we will deal with the B just to save time. So B, okay, you extract what you are giving. So giving,
Mr. Hackman,
yes, please, my professor.
please, after you find the difference, are you supposed to add the cardinal point in which you can find the difference after you
Oh
have
no, we are
gotten it?
looking at difference in angle. So it's the angle that we are looking for. The angle will not have direction.
Yes, please.
Is that
Thank you.
okay? We are finding
Yes,
a
please.
difference in angle. So it means basically we are finding an angle. Is that clear?
Yes, please.
Okay, very good. All right. Okay, so we are done. Don't go and attach anything. So giving, okay, you extract your 2 points here, the C and D. Okay, you equally come in. Okay, I think I have to do that. So let me, so that those who were not here at least will have, because going forward we'll be doing, okay, that a lot. So let me see if I can pick, okay, so let me go and pick, okay, one of the, let me pick this. Just copy and paste here. Okay, so clear this and paste it, okay, and move. Okay, all right. So that I would waste time drawing the line. So it will be there for us to work on. Okay, so let's go. We are good to go. So now we've indicated our north, our south, okay, then our west, our east. Okay, but this is 0 degrees. Okay, don't forget. Even if you don't, you should know that that's 0. This will also be more or less like your 0. So now let's go. The point 10 north, 10 degrees north. So it means I come. So this is 10 degrees north. That is my latitude for the first, okay, point, okay, C. And that is 10 degrees north. So I indicate 10 degrees what north. So 10 degrees away from the equator. Okay, so north. Am I right? Am I right?
Yes.
Hey, my professors, it means you are
No,
not following.
please.
No,
You
please.
know, this equator is dividing this into south, okay, and north. So if it is north, then it should be in this hemisphere. So this is the northern hemisphere and the southern hemisphere. Is that clear? Is it clear now? So
Yes.
Yes.
that cannot be. So please take note. This one was intentional. You know, if it's not intentional, I will tell you. Okay, so now we are supposed to clear this. That's not so you have to be very careful. If you place them wrongly, you know the diagram will always attract marks. So you can possibly lose the marks for the diagram. So make sure you do the right thing. Consider north and south. You should know your north from south and what west from east. Okay, so quickly, let's go. So 10 north means I need to come up. Okay, north is up above this line. So I'm going to indicate it this way. Okay, and that will be 10 degrees north. Okay, then the other one, what is the longitude? The longitude of what C is 20 degrees east. So east is what is rather here. So you don't draw it here. So as for the longitude, they converge at the true north and what the true south. So we are going to draw it this way. Don't forget, remember what we did yesterday. I'm trying, I know. The digital board, even with a digital board, my curves are not that crooked. Okay, so now what do we have? You move, this is what your 20 degrees east, okay, longitude. So where the latitude 10 degrees north and the 20 degrees east longitude meets, that's where your point C is going to be. All correct, my professors. Okay, so now it's left with our second point, D. D, what are we going to do? It's 40 degrees south, so south you have to come down. Remember 10 is this, so 40 means the distance from here to where you draw your arc, okay, indirectly or your curve, okay, should be bigger. So though you are not drawing to scale, it should still make sense. So I am going to bring this one down, okay, more. Okay, so in actual fact, this will give me 40 degrees south. I hope you are following my professors. Is my point well made? My professors, are you following?
Yes.
Yes, sir.
Okay, so where this latitude that you just had drawn and the longitude that you've already drawn meet. So because its longitude will be the same, 20, which is already drawn, so you don't go and draw it again. So that will give you your point D. So he indicates then that will be the point D. Okay, so this is the point. So if you are supposed to look for the angle, you take the angle from the origin where they meet, the two special lines where they meet. That's the equator and the meridian, Greenwich meridian. So from here to here will be a line up to this point, up to this point. So indirectly, we are finding this angle. Is that clear?
Yes.
Okay, very good. So now in this case, we are going to write therefore difference in angle will be equal to, so now this one too, they have a common longitude, so we have to use their latitude. But the latitude, if you look at it carefully, you see that the latitude, are they in the same direction or opposite direction? This one is north, this one is what, south. So opposite or same?
Opposite.
Opposite. And we said opposite, what do we do with their angles?
We add.
We add, as simple as that. So it means your difference in angle will be the 10 degrees angle that you have there plus what, your 40 degrees angle that you have there, which indirectly will give us what, 50 degrees. Point well made. Point well made. And the reason why I had this diagram done is for you to know the concept behind re-adding when they are in the opposite direction, and subtracting when they are in the same direction. So let me start from the, what do you call it, the opposite direction. So you can see that now this angle that you have here is the angle that you moved. I'm talking about from here to, from this line. Okay, to this, that's the angle that you move to get your C. So that is the angle, here. That is, so the, from here to the C is 10. So this will be 10. Okay, that is between these two lines. And from here to this will be your 40 degrees. So if I want to know the entire angle here, you can see that I have to add. Can you see that? From here to here and now from here to here. So the entire angle will be this. However, so this one is talking about when they are in the opposite. Okay, however, if they are in, what do you call it, the same direction, this is exactly what I'm going to do again. So take note of that. So indirectly, I'm also going to assume I am measuring my angle from the positive or 0 degrees angle. So I'm measuring it from here. So it means indirectly, I know that the angle from here to here, I'm just assuming. So from here to here, okay, so from here to here is what? What is this point? The point B, what is the latitude? From here to here, I'm waiting. Oh, I'm waiting. Oh, the point B, what is the latitude? Oh, it's supposed to be B. Sorry, I changed it. Okay, so I didn't change it when I was extracted. So now, oh, my professor says I'm waiting. Let the class be interactive. It's what? Oh,
76.
okay. So do you think it is this angle that will be 76? Okay, so let me write it there. I'll play on your intelligence a little. So 72 degrees. And from here to here will be what? I'm waiting. Wow. Hey, you people should know this. So, my professors, the way I believe you people, and you are not bringing out certain misconception that I'm throwing to you. Okay, I'm surprised. Okay, no, anyway, we don't have time for me to be playing on your intelligence. So let's go. So this is it. Just as we did in trig. Okay, all your lines will be located in a particular quadrant. So if you are measuring your angle, you measure the angle relative to the, let me call it the x-axis in that quadrant. Okay, you don't take it from the positive x-axis. So if that's the case, then this is what I'm going to do. So let me clear this. Okay, then do the needful. I was expecting you to. This can obviously, you will see that it doesn't make sense. Okay, with this one, look at what we did here. With this particular one, okay, we took, because you can see that this point is in this quadrant basically. So we will measure it from the angle from this line, your baseline, which is the x-axis. So we moved up. This is also in this quadrant. So we measured it from the x-axis in that quadrant. So we moved down. Is that clear? Is my point well made now? Is my point well made now,
Yes,
my
please.
brothers? Okay, so if you come here, look at the point A. It's in this quadrant. Do you agree?
Mr. Hackman, please, I can't see your cursor.
You can't see my cursor. Okay, so let me use this. Okay, so the point A is in this quadrant. Do you agree? I hope you are with me.
Yes, please.
Okay, the point B is also in that quadrant. Is that not it?
Yes, please.
So it means if I'm measuring the angle for A, I have to measure the angle between the line through the A and the x-axis in that quadrant. So it means the A angle here is what? Is which angle? The angle that we have here, which is 20. Do you agree now?
Yes, please.
Okay, then the B angle, it will be from the same x-axis in that quadrant, okay, to your B line, okay, from the origin. So it is the whole of this angle that will be 76. Do you agree?
Yes, please.
Okay, so now we are looking for the angle between these two lines. So you can see that here you move from here to here, which is 76, and you move from here to here. So if you want to know the angle here, you know from here to here is what? 76. From here to here is what? Is 20. So if I want to know this, I can easily get it. How do I get it? By subtracting the 20 from this. I hope you get the point. Do
Yes,
you get,
please.
you get my point, right?
Yes,
Yes,
please.
please.
Okay, so this
Yes.
indirectly explains why, okay, when the angles are, the direction of your angles, I'm talking about whether latitude or longitude, if they are in the same direction, okay, we subtract, but in the opposite direction, we add. So indirectly, I have explained that. So once you know that going forward, it will not be necessary for you to, okay, you can get the difference in angle without struggle, without doing all the analysis here, because basically that's how we were supposed to teach without giving you the formula. And now that you know the formula, I've given you a simple way to get the difference in angle. That's what we are going to use. So now let's move on to the next one. Okay, so with this one, I don't think it will be very difficult. We are not going to draw. So now that we know the concept, we'll get the angle difference or difference in angle straight away. So solution to question 2. A, you extract what you are given. So given your 2 points are, okay, S, so you extract just because of time. So you extract, so you just copy and paste this one here. Okay, then we come to, therefore, difference in angle. Is my point well made? Okay, but
Yes,
here, well,
please.
let me see the other one where we asked to find, okay, so once we were asked to find the angles, then we would have concluded by saying the angle, okay, instead of writing difference in angle, okay, because the question didn't ask us to find difference in angle. So you conclude based on what you have here. Okay, so please bear with me. So therefore, but the angle that you are looking for is basically the difference in angle. So if you don't see the difference in angle, remember you are finding the angle between 2 points. So it will always be difference in angle. Usually when we say difference, we are talking about subtraction. Okay, but in this case, at a point we will add. So I'm going to go strictly by the information provided just for me to, so what am I looking for? I'm looking at the angle between, okay, so angle between. So let me go and pick that. Okay, so therefore, okay, the angle, we are finding an angle. So therefore, okay, angle will be equal to. So we know, okay, these 2 points, what did they share in common? A common latitude or a common longitude? These 2 points. The whole class, S and T, what did they share in common? Latitude or longitude?
Latitude.
Latitude. So it means we have to use which one to determine the angle or angle of difference?
Longitude.
Longitude, as simple as that. You get the point. So now we are going to use the longitude, but what do we do with the longitude? We consider the direction. So if the directions they are in the same direction, then it means we have to subtract to get the angle. So here, okay, the longitude, the first one is west. The second one is also west. So west, west. So it means we have to subtract. So the difference in angle will be the bigger angle, 58 degrees, minus the smaller angle, 20 degrees, which in effect will give us what? 38 degrees. Afa, my professors, are you there? Have you been able to connect
Yes,
fully?
please.
Okay, then let's look at that of the B together. Okay, so B, you leave a line. Okay, what are we looking for? Angle between. So therefore, the angle that we are looking for will be equal to. Okay, so now we are going to get what? These 2 points. Okay, but I didn't even extract in my usual way. So forgive me, it wasn't intentional. Where am I in a hurry to? Okay, I looked at the time and okay, that's disoriented me. So I'll write giving, so I will extract my 2 points. Okay, so you know your S. So in this case, P. Okay, you extract. Okay, and your Q also extract. Okay, so now what do? We come to therefore we are looking for an angle between these 2 points, and that will be equal to. So let's see the 2 points. What do they have in common? Longitude or latitude?
Latitude.
Latitude. So it means we have to use again the longitude to determine the difference in angle or the angle between them. So in this case, what do? This one, the direction of the angle here, okay, of the longitude is east. The second point, its longitude, the direction is west. So when the directions are opposite, what do? Do we add or we subtract?
Add.
We add. Okay, so it means we are going to get the difference in angle or the angle between them to be 85 degrees plus what? 14, okay, degrees. Okay, which gives us 99, 99, okay, 99 degrees. Do you agree? My professors, are you there? Do you agree?
Yes, please.
Okay, very good. Okay, so at this point, I believe you should be able to do this. So we are going to do, okay, this, okay, mentally. So maybe I'll call you one after the other to give me your answers. Okay, or I will ask you to give me your answers, okay, okay, via chat. Okay, so the Zoom chat. Let's look at the A. Please give me the difference in angle, okay, for the 3A. Okay, I'm waiting. Let me pause. Okay, wait for your answers. We'll check when you come. So I'm giving you about a minute, okay, to give me this one. You can do it by inspection. So give me your answer, direct message, not a general message, please. Okay, so sorry, I didn't resume recording. Okay, so I will briefly go back so that I'll capture all that I said, okay, in the video. Please pardon me. Okay, let's ask, okay, quickly go back. Okay, so we are going to go back a little. Okay, so we were looking at finding the distance between two, okay, points on the same, okay, circle, the Earth, okay, surface. And your distance that we are looking at will be the distance along a great circle. So it will be the length of an arc. If the arc will be on a great circle or on a small circle. So going forward, okay, the worked example, I will talk more about that. How to determine that your distance will be along a great circle, a small circle. So if it's the distance along a great circle, we are talking about the arc length, arc distance. Okay, so that will be given by this. Okay, arc is part of a circumference. So where we said theta sub d is the angular distance between the 2 points, which is the same as the difference in angle between the 2 points. Okay, so and r is what? The radius of the earth. Okay, that's coming from a great circle. So the same thing for the distance along a small circle. So that will also be an arc length. And I said, if you go back here, you can see that the distance that you are looking at between these 2 points will be the distance, okay, here, which is the length of an arc. Okay, so you have to always use the length of an arc, but the arc will depend on a particular radius. If the radius is big R, then it's coming from the gray circle. If it's small r, then it's coming from what? A small circle. But small r has its relation in terms of the big R. So this should have been 2 pi small r. But small r we know is r cos theta. So that gave us the formula that we have here. Okay, so please take note. Now, our first word example, this is what we have. Remember this diagram, we had it drawn in the situation where we are finding the angle difference. So you should be able to relate with the diagram that we have here. Only that here, after drawing the diagram, the question asks us to find the distance between the 2 points. So the diagram is trying to tell us that the distance between these 2 points will give us the distance along an arc, or the arc length. So in this case, you come and draw, you know, okay, it means you are dealing with a circle, you know. Okay, this is part of a circle. A semicircle will be here. The other part will be on the other side. This normal circumstance is supposed to be a 3-dimensional figure. Okay, so this is, but we cannot draw that 3-dimensional figure. So the other half will be on the other side. Okay, so this is how it will look. So if you come and draw the circle, that will come out of it. These 2 points will be here. So you are finding the distance here, which is the length of an arc. And the arc is supposed to have a radius. I'm talking about a circle that you have. You need the radius and you need this angle. Okay, the angle between the 2 radii. So the radius here will be big R because we know that the arc is along a longitude, which is a gray circle. So in this case, this will be a big R. Otherwise, it will be a small r. How do you find the angle here? The angle is the angle here. That's the angle between these 2 points. The angle, difference in angle. And we know we have to use our technique in finding the difference in angle. So because the 2 points, they have the same longitude, we use the latitude. The latitude, they have same direction. So same direction means we have to subtract the angle, the smaller one from the bigger one. And that gave us the 56 degrees here. So you come and quote your formula, let the formula guide you in your carrying out your various values of the parameters. So theta sub d, you found it. R, the question has given you the big R. Okay, pi you are given. So you substitute. So I'm waiting for your answers now. Okay. So if you substitute, your calculator gives you
6,257.77.
Okay, mention it in terms of, so that if it doesn't, in terms of digits. 6.
1,000.
So 6.
6,257.77.
0.77.
Yes, please.
Is it exact?
No, 77.
But I told you when you are approximating, your first approximation should be how many DPs. Please be careful. Oh. Don't just write as if you are possessed. You've been given information, so make use of the information. You've been advised. Go by the advice. Don't lose these low-hanging marks. Okay, so I need 4 decimal places approximation. Even yesterday I said it. So it will be 7.
0.7778.
778. Okay, it was 7 recurring.
Yes, please.
Okay, so if it's recurring, then you can give the exact value without approximating. So if it's recurring, you know how to deal with that one. So I will not write it for DP. As if you write it for DP, that's okay. But if it's recurring, then it means you can get the exact without writing. The reason why we approximate is that we don't want to write all the decimals. Okay, just to save time. So for DP will be okay. However, in this case, it's exact because it's recurring. So this is what you do to bring out. You were taught this. So Km will be here. If it's 7 recurring, then you put your dot on top. So it means you have given us the exact value rather than the approximated value. Do you get the point?
Yes.
My professors, are you with me? So that's why you were taught how to write decimals, in terms of recurring. Okay, thank you. So that will be it for the question 1A. Okay, so let's go and look at that of the B. Okay, my professors, is my point well made? So after the B, then we go for our water break. So let's finish this. Okay. So the B indirectly. Oh, okay. So I've done that. I think I did complete this one. I duplicated. So okay, let me change. Let me do the corrections before I forget and send you the slide, which will be so. Okay. All right. Okay. So at this point, we are good to go. We are looking at the B. Okay. Again, you extract your 2 points. Okay, the C and D. Then you come and draw. Remember, we have already drawn that one. So let's do that again. So C. So don't forget to indicate your west, your east, okay, your north, your south. It will guide you in placing your latitude and longitude. So now C, 10 north. So that will come up. So 10 degrees north. Okay, and the 20 degrees was east. So that will be our longitude. Okay, so longitude 20 degrees, okay, east. Okay, then so this is where your C will be. D, what are we looking for? Okay, 40 degrees, okay, south, 40 degrees south. So south will be here, so I come down. This is 10, so 40 should come down more. Okay, so let me curve it a little. Okay, so that would be give you a 40 degrees south. Okay, so where and the 20 degrees east, you've already drawn that. So that will give you your point D. My professors, are you with me?
Yes, please.
Okay, so yes, remember I said it. Okay, you are supposed to draw these two. The first one is for the exact picture, and the second one is for you to know that you are dealing with a circle, and therefore you are finding the length of an arc, okay, on that circle. So these two must be drawn. All that I'm doing here, you are supposed to do it. So please take notes. All right, okay. So now what do we do at this point? We know our 2 points, C and D, okay, and we are asked to find the length, okay, here, the distance between C and D. So C and D, we are talking about the distance here. Okay, so the distance here obviously will be length of an arc. Remember, this part is what? The arc that you have is a semicircle. The other half, okay, will be, okay, at the back. So just to explain. But when you are drawing it, it's not necessary. Okay, you are looking at. So at this point, this is what we are looking at. We have 2 points. You can fix them anywhere on your second circle. Okay, so this is what you do. I'm going to pick my 2 points here. Okay, which will be C, then D. Okay, then center, I will need my radius. Oops. So you are supposed to use a straight line here. Please take note. Okay. All right. So going forward, the others I will draw the lines, okay, better using the way. Then after that, okay, I will do copy and paste. So now let's look at, okay, the arc that you have here. Is it along, okay, a gray circle or a small circle? It's along a longitude. Can you see that?
Yes, sir.
Okay, so and once you know the longitude at gray circle, it means our R here will also be big R. Okay, now we need to come and find this angle. Okay, by then maybe you have quoted your formula. So, and the formula will talk to you, but per experience, you can do this before quoting the formula. So now, what do? We need to find this angle because we are dealing with arc length. So we can say therefore, arc length, okay, which is the distance CD. Okay, or let me even put it this way so that you can relate better. I think I know you, so I should be able to teach. Okay, so therefore, distance, okay, distance I know, okay, will be equal to arc length AB. Okay, so arc length AB is given by the formula theta Okay, sub
Mr.
D.
Lukman.
Yeah, oh, it's CD, right? I guess that was what you were drawing my attention to.
Yes, please.
Okay, all right, I've been able to read your mind. Okay, so now this is what we have. So it's supposed to be arc length CD. Then from that, it wasn't intentional. Okay, so theta over 360, okay, degrees, then times what? Okay, 2 pi r. Okay, with this one, you can choose not to write theta sub d. Okay, it's because of the other one. The other formula has two thetas. So we needed to distinguish between the two. So let's come here. You can see that there is a theta here and there is a theta here. Okay, so we needed to distinguish between the two. That's the more reason why there is theta sub d here. Otherwise, you can use maybe alpha for this or alpha for what we have here, just to distinguish between if you don't want to use theta sub d. I usually tell students to use theta sub, but that you know that the d is talking about difference in angle, and it will take you to what you are supposed to. Okay, so quickly, here we know only, we are looking for only theta, but now what will be your theta? Your theta will be this, your difference in angle, you should know. So theta, the difference in angle, let's go and find the difference in angle. With this one, you can see that they have the same, okay, longitude. So we use the latitude. The latitude are in opposite direction, different direction. So we'll add to find the difference in angle. So what do we get here? We'll also get 50. Is that not it? Is my point well made, my professors?
Yes, please.
Okay, so let me go and erase, okay, and draw it better. Okay, so that you can clearly see the angle. So this will be 50, okay, degrees. So now it means this will be equal to 50 degrees over 360 degrees, okay, times what? 2 times pi. Pi we are told is 22 on 7 times your r, which we are also told is what? 6,400. You ignore the unit, so that will be equal to whatever that you get, you attach km. So I'm waiting for your answers. I think it's the same thing, right? Did you get 50? No, the other one you had 56, right? Or it's 56, so you cannot give her the same value. I am waiting. Hope I'm recording. Yep, okay, I am. This time around, I have to be careful, knowing that you are not watching my back. No, you need the video more. So let's go. What did we get, Prof. Bushra? So I know that you have the calculator. Let's go. You are rounding it to 4 dp. If you don't have the exact value. Oh, we shouldn't waste time, our professors. We shouldn't waste time on this. Hurry then, let's see.
5,000.
Okay. 5. Okay, so
587.
5587 points.
3016.
16. Okay, km. And once this one you approximated, you indicate your approximation 4 dp. All correct. My professors, is that clear? Okay, so at this point, I think we can comfortably go for our water break. Okay, so I'm giving you 5 minutes water break. Okay, so when you come back, then we continue from where we left off. Okay, so please, you are welcome back from the water break. So let's continue from where we left off. All right, so obviously you can see we are looking at question 2. Question 2, so solution to question 2. Okay, again, what are we supposed? You are supposed to find the distance. Okay, so 2a. Okay, you extract what you are given. So given your point S, okay, you extract, and your point T, you equally extract. Is that clear, my professors? Just to save time, you will write it, okay, but okay, I am not going to. Okay, I've guided you as to what to do, so you will do the needful. So now let's look at the first one. Okay, so the first one, what are we looking at? We are looking at 25 degrees south. So let me see whether this one is going to be on a common. Okay, so we'll still get. Okay, so let's move on. We'll get it, don't worry. So let's go. What do we have? 25 degrees south. So remember, this is your west, your east, your north, then your south. So we are looking at 25 degrees south. So south will be here, 25 degrees. So you know, that's where your first latitude will be. So 25 degrees, okay, south. Then its longitude will be 20 degrees west. So west is here, 20 degrees. Okay, and you can see that the other one will be 58. So this one should be closer. Okay, so 20 degrees. Okay, it's an arc. You should look and converge there. Okay, it's not looking that pretty, but don't worry. Okay, so this will be my 20 degrees west. Okay, angle. Then the other one, okay, if I come, so this is where your S will be. Do you agree? The point S. My professors, are you with me? I hope you are following.
Yes, please.
Okay, now we are left with our second point. Okay, second point, 25 degrees south. We already have it. Okay, so let's go to the other one, 58 degrees west. So 58 degrees west. Okay, so we are going to do it. So that one will also be here. So it will be a bit away from that. So that is the 58. Okay, so please take note. Okay, and you come and join. Okay, to meet here. So that is your 58 degrees west. All correct, my professors. So where the latitude and the longitude here they meet, that's where your point T is going to be. All correct? Okay, so we are asked to find the distance between S and T. So it's this distance which will give us an arc. So the other half will be, okay, at the other part. So in this case, we are looking at the distance, okay, T, then what? S or ST. Doesn't really matter where you place them. Only that usually I'll use, okay, the position. This is to the left, then to the right. So that's what I do, but it doesn't really matter. It's the same thing. So now what do we have here? We know, let's see. This time around, let's see. The TS or ST, is it on a common latitude or a common longitude?
Common latitude.
Common latitude. So it means the R here, is it going to be big R or small r?
Small r.
Small r, because the circle that will come out of it, okay, the arc length will be that of what? A small circle. Now, professors, I hope you are with me.
Yes, sir.
Okay, very good. So now this will be small r, okay, which you know its relation. So I'm writing small r there, but you know that it will give us big R cos theta. So we'll deal with it later. Okay, so now let's do, maybe you can also write that one here as big R cos theta just to remind you. Okay, all right. So, but it will be okay. So now let's see. Okay, now we need the angle here. So this time around, we are going to quote the formula. The formula will tell us that we'll need the angle. So in this case, I'll write, therefore, I know that my distance that I'm looking for, distance, okay, that I'm looking for will be equal to arc length arc length, okay, of what? ST, okay, which will be given by the length of an arc is theta over 360 degrees, okay, times what? Okay, it will be 2 pi small r, but small r is big R cos theta. Is my point well made? But we know that we have two thetas, so we want to
Yes, please.
distinguish between them. So you can write this as sub d. So that when you do that, then it means you write theta sub d here in your diagram for us to know that that is the angle that is here. But the theta, remember we said it will be the common latitude. Okay, so let's go and find our difference in angle here. So the difference in angle, I think this was the one that I asked you to do. Okay, and so let's see. The difference in angle, okay, they have a common latitude, so we'll use the longitude. The longitude, they are in the same direction. So we have to subtract. I think this was the one that you were given, then you gave me the 38 degrees. Is that okay? So the difference in angle, which is that theta sub d, will be 38 degrees. All correct?
Yes, please.
All right. And like I said, it's just a formula, so you can quote it in your own parameters, only that you should appreciate the parameters that are there. So if you use theta here, you can use alpha for you to know that your alpha will rather be the common latitude. Okay, then your theta will be your angle of difference. That's all. Okay, so now this will be equal to theta sub d is what, 38 degrees over 360 degrees. Okay, times 2 pi, we are giving this one, were we giving pi? Yes, it's also 22 on 7. Okay, times your r. Oh, sorry, yes, times your r, which is what, 6,400. Then cos of theta. So what do you think theta will be? We said theta is the angle of what? Common latitude. So what is our common latitude?
25 degrees.
25 degrees. So the theta is for the latitude. Okay, so that will give us, because the theta, the r cos theta, the r small r came in because of the latitude. So the angle there will be relative to that. Okay, latitude, and that is what? 25 degrees. Alpha.
Yes, please.
Okay, so at this point, okay, calculator will work. Okay, only that I will entreat you to use your calculator to do this part and your calculator to do the course. But you can use your calculator to do everything. So do this part, but don't do the course. So do only this part for me without the course. Okay, you can reduce. Okay, use your calculator. Is now calculator use. Okay, so use your calculator to give me the values. Okay, I'm waiting.
0.6635.
Everything, right?
No, please,
No,
the
everything
first
cannot
part.
be. The first part, okay, so give me everything
No,
together with the cost. Other than that, you approximate here and come and approximate here too. I want us to reduce our number of approximation because it can move us away from the actual value. You get it?
yes, please.
Okay.
3848.
3848.
0.499
9
kilometers.
recurring.
No, please, 994.
994. I hope you check the next digit. Okay, km. And here you approximated, so you indicate your approximation for dp. All correct. Safa. So now you know how to find the arc length if it's on a great circle, the arc length if it is on what? On a small circle. Okay, so please take note. Okay, do we necessarily have to do one more for this particular one?
No,
Okay,
please.
so I think the understanding is okay, well noted. Okay, so if that's the case, then let's go and look at, so with this one, okay, you can try this. Okay, basically, okay, the same thing, finding the distance between two, okay, points. Let's go. Okay, so here, so this is, okay, the one that I need to give you extra information, especially because of the B. Okay, so we are going to look at question 4. All right. Okay, so question 4, having skipped, okay, the other questions, let's see, question 4, so solution. So let's read this on the surface, find A. So question 4, okay, we are going to look at what? The information that we have here will be a general information. Okay, so please take note. We are finding the distance between A and B. So we are going to extract the general information. So here we are asked to, so giving our general information will be the 2 points. Okay, so A and what? B. Is my point well made? So that's your general information, and your 2 point very critical. So that's what you extract first. Then now we are not going to look at A. Okay, we'll draw this, okay, as a general information, then we come and look at A. so that we can use this diagram to do both A and B, all the diagrams. But if I come and write A here, then it means this is particularly for only A. Okay, I can, if I'm going to do B, I have to rely, I draw it again. I guess you get my point. My professors, are you with me or I should come again?
We are with you.
You are with me, all right. Okay, so now let's go. So with this one, okay, let's go and draw, indicate our point. A is 30 degrees north. Okay, so remember, this is north, south, okay, west, okay, then east. All right, so now we come towards 30 degrees north. So 30 degrees north will be here. This is 30 degrees north. Okay, so you indicate your 30 degrees north. Okay, that's our first latitude of the first point. Then 25 degrees west. So 25 degrees west is going to be here. Okay, so I indicate this my 25 degrees west. Okay, then, okay, where they meet, that is where I will locate my point A. Okay, let me come to my point B. 30 degrees, okay, north. I have drawn that, okay, latitude. So 35 degrees east. So east will be here. So it means I'm going to, but because here to here is 25, 35 should move a little away. Okay, more from that. Okay, so though you are not drawing to scale, it should still make sense. Okay, so this is your 35, okay, degrees, okay, east. Okay, so at this point where these two meet, that's where, okay, your point B will be. All correct, my professors?
Yes, please.
Okay, very good. Okay, so at this point, okay, we are in a comfortable lead. So we are asked to find A, so we are going to look at A. Okay, we are asked to find, so therefore, distance. You know it will be equal to arc length. Arc length, okay, what? AB. I hope you are with me, my professors.
Yes.
The length of the arc AB. Okay, so that will be given by the formula. So you know, let's see, we know the length of the arc, it could come from a small circle or a great circle. So let's go and make that determination because it will guide us to the exact formula to quote. So in this case, let's see. Okay, the 2 points, they are on a common latitude, true or false? A common latitude, is that not it? And latitude, this latitude here is not the equator. So it is what? A small circle. So it means here we are going to get our R. Okay, so let me write small r, which we know is equal to big R cos theta. Point well made. I think it's not, my handwriting is not coming out clearly. Okay, the digital board, it's not that friendly to use sometimes. Okay, so yeah, it is big R cos theta. You can choose not to write it here and later go in, but I just want you to follow. So let me do this and cancel so that it will be easy for you. Okay, so that's what, so in this case, it means we know our A, this is the point A, this is the point B. Okay, however, we need to know this angle. Okay, which we will refer to as theta sub D. So theta sub D. Okay, so now theta sub D will be the angle of difference. And you can see that here, okay, the 2 points, they share a common latitude. So we use the longitude. But the longitude that we have there, they are in different direction, opposite direction. So for us to get the difference in angle, what do? We add, Abby? We add, is that not it? So that will give us 35 degrees plus 25 degrees, which will give us what? 60 degrees. All correct? Okay, so we are in a comfortable lead. Now we know that we are dealing with a small circle. So the formula will be theta, okay, sub d, all over 360 degrees. Don't forget your degree times, okay, 2 pi small r, but small r is r cos theta. All correct.
Yes,
Our
please.
professors, are you there? All right. So at this point, this is what we are going to do. So we are going to get, let's go. That will be equal to, So theta sub d, we agreed we had, okay, 60 degrees. All over 360. Don't forget your degrees. So 360 degrees times, okay, then what do we have? 2, okay, pi is giving us what? 3.14. Okay, so use the one that is given, then times your r is 6,400, then cos what? Theta. So cos theta. Theta is our angle of our common latitude, and our common latitude here is 30 degrees. Do you agree?
Yes,
Our
please.
professors,
Yes, please.
Afa, is the explanation
Sir,
okay? Hope I'm teaching well.
sir,
Yes, please.
Yes, please. Okay, someone called me.
please, I wanted to ask how you got the 60 degrees.
Okay, so the 60, were you with us from the beginning?
Yes, please.
Okay, so we are finding the 60 will be, remember the angle here will be the, so we said theta sub d, the difference in angle. And the difference in angle, we said we check. If the 2 point, they have a common, okay, latitude, longitude, we go and use the other, okay, to determine imaginary line. So here, they have a common, okay, latitude. So we have to use the longitude to determine that. Okay, so the longitude that we are using to determine, we will use its direction. Okay, it's either we add or subtract, but that will be dependent on the directions. If they are in the opposite directions, we subtract to get our difference in angle. If they are in the same direction, we subtract. Okay, if they are in the opposite direction, we add. So here, one of the longitude is west. The other is what is different direction. So we add to find the angle of difference. If they were in the same direction like the other one, we would have subtracted. If this one was west, we would have subtracted, okay, 25 from 35. If this one was east, we would have subtracted 35 from, 25 from 35. But once it's west, east, different direction, we add. Is that clear?
Yes, please.
Okay, that's
Sir,
where yes, please.
so you add the 35 and the 30.
No, you add you are using the longitude. So the two longitude will be what you add, the two longitude from each of the points. And if you were with us, we move from that point, so you've gone beyond how to find the difference in angle. And you didn't talk there. We've gone beyond this. Okay, we did a lot before we came to, because I told you that we would need it. So that's the more reason why we spend more time there. So you use the common, that's where we started even. So if you were with us from the beginning, then this shouldn't have been a challenge. So common longitude, you use, latitude, you use the longitude. The longitude that you have there, if they are opposite in sign, okay, you add the longitudes. You don't add this one is not a longitude, so you can't add this angle and this angle. I said add, okay, the longitude angle, and the longitude angle, you have 1 year, 1 year. So you add if they are in the opposite direction, you subtract if they are in the same direction. So you deal with the longitude angle. So if you have a common latitude, if you have a common longitude, then we use the latitude, either add or subtract, depending on the directions. Is that clear?
Yes, sir.
All right. Okay, so it means you have to watch the early part of what? Okay, the video. Okay, because that's where we started from. So at this point, we are in a pole position. The rest will be a calculator work. So I'm waiting. Your calculator can do the whole of that. If you want to reduce before you saddling your calculator with that, okay, it's allowed. So let's go, whatever kilometers. Yeah, I'm waiting. By now, someone should have been done.
501.2.
5801.
5801.
Yes.
A point.
2, 1,
Mm-hmm.
215.
5.
215.
215. It's exact.
No.
2155.
Yes.
Okay. All right. And you know you approximated, so don't forget to indicate your approximation. That is 4 dp. All correct.
Yes, sir.
So that will be the distance. So now let's go and look at the B. Okay, the B is just an extra information. Okay, so let's look at
Yes.
this. The B you are asked to find, you can see the first one is just the distance between A and B. The second one, the B, the distance has been qualified. Can you see that? Or shortest is
Yes,
not an
sir.
adjective. Okay, so in this case, your distance has been qualified. The distance between A and B that you are asked to find has been qualified. And once it has been qualified with shortest, this is all that you need to know. What is the shortest distance between 2 points? I've asked this question before. The shortest distance between 2 points is, wow. My professor says, oh, you can't hear me. The shortest distance between 2 points is, oh, my professor says, this one there, I can't hide it. I'm disappointed. Unless maybe you know and you don't want to tell me. I've asked this before. I remember I've asked this one when you were doing the coordinate geometry, either 1 or 2. Okay, the shortest distance between 2 points, okay, is a straight line. I hope you get it now.
Yes, please.
Okay, so it means here the question wants you to find the distance that you have here. A straight line joining these 2 points, which will be a chord. So find the length of the chord AB rather than the arc. Afa, hello, is my point well made?
Yes,
Yes.
please.
Okay, so in this case, I'm going to write, okay, shortest distance. I know will be equal to, okay, length or chord length, AB. Is that okay? So this time
Yes.
around, it will not be an arc length, it will be a chord length. And remember what we did in mensuration, how to find the length of what? Of a chord. Okay, so if you want to find the length of this chord, you know. If you want to reproduce, you can still do your analysis here. So you are going to do this. Okay, or you are even mature. Someone can, I think I even said it in the mensuration. Someone can use, okay, because this is known. The arc cos theta is known. This is known. This is also known. And this angle is known. Someone can use the cosine rule to find the side AB. That is one way. Okay, someone can also find this R. This R will be known. I'm talking about small r because it will be R cos theta. You know the R is given, your theta is also known. So it means you can find this. Okay, once this is known, we will do it, but I'm only explaining, guiding you, so that when I'm presenting, okay, I can flow. Then you draw this, once you draw this line, this will be the height. Okay, so this height, which will be perpendicular to this, will bisect this angle here. So this will be 30 degrees. Okay, and equally bisect this side. So this side here will be equal to this side. Is my point well made?
Yes, please.
Okay, so in this case, this is what we are going to have. So let me label this side. I think, should I even label it? Okay, let me label this O and label this D or C, just for me to make my point. So if I'm considering a particular triangle, okay, this particular triangle that I have here, I can find the length here. My professors, are you there? My professors, are you there?
Yes, please.
Okay, so now we are going to find the chord, okay, AB. So I am going to extrapolate, okay, whatever that we have here. So let me do that as a rough work. So my triangle there, okay, this is 90, this is 30 degrees. Okay, then, okay, let's find this. Do the r cos theta for me. Do this for me. 6,400 times cos 30 degrees. My professors, are you there?
5542.
It's what?
5542.
5542.
Point
Mhm.
5626.
26. Okay, that is for 4 DP. Is that not it?
Yes, please.
Okay, all right. As for the presentation, we've done that in the mensuration. So I could have referred you to go and look at the mensuration presentation, then, okay, you follow suit. Okay, because you are all supposed to have watched that particular video or lesson. Okay, so now, okay, so this is what we are going to do. I am going to use the cosine rule because I don't remember using the cosine rule in that one, in the mensuration, so that you have liberty, okay, the flexibility in dealing with it. So I'm going to use the cosine rule. I won't do this. So I'll go and write, okay, this, okay, this will be equal to, I know that by the cosine rule, I'm going to get this will be equal to the length of this arc will be root of. Are you with me, my professors? So let me use the cosine rule. Those of you who don't know the cosine rule, at least it will give you a fair idea. So I'm not going to use this. Okay. This one, I think, like I said, I did it in the mensuration, so you should be able to. So you know, I'm going to quote the cosine rule here. You know, by the cosine rule, the length of AB, okay, it will be this one squared will be equal to, so it will be root of. Remember, it will be here. Let's go. If it was this one squared, that will be here. My professors, we shouldn't waste time on this. So cosine rule should be, and I was the one who taught you trig. Okay, in fact, almost all of you here. So let's go. Let's quote the cosine rule. Oh, my professors. Oh,
OA squared.
what is happening? So what will give us? So what will be the answer that we are supposed to get? The length of AB will be equal to,
The length of OA squared
okay, so OA squared,
plus the length of OB squared. So we
perfect,
can replace it with the minus 2 the length of OA times the length of OB cos 60.
cos 60, oh, no. Okay, 60 degrees. So that is what we are going to quote. So that will give us what? So you quote, if you quote it up here, you now come and substitute. Is my point well made, my professors?
Yes, please.
Okay, so this is supposed to come up here. You know your OA is the same as what? Your OB. Because this side is equal to this radius. This side is equal to this side. Okay, any other means that you think we can find that? Okay, so whichever means that you think is okay for you, you go and what? And adapt. It's my point well made. I'm not, as for this one, I'm not going to do it for you. You should know how to deal with it. Yeah, my point that I wanted you to know is that anytime you are asked, so the more reason why you have this question, Okay, here is for you to know that you are dealing with the length of a cord. Okay, that's all. How to find the length of the cord, like I said, we treated that in mensuration. So if you have not watched that video, go and watch it. Then as for how you present your solution, you should be able to follow suit. Afa,
Yes, please.
okay, so on that note, you should be able to deal with whatever that we have here. Okay, so distance and shortest distance. So just the distance is the arc length. Shortest distance is the chord length. Take note of that. Okay, so I think with this, let's see. Okay, all right. So this one is not too straightforward. I will help you extract the information that you have there. Okay, I mean the basic information in your usual form. Okay, or usual way. Then after that, I will guide you to continue. So we are not going to do everything together. So P and Q are two towns on the Earth's surface on latitude 56 degrees north. Their longitudes are 25, is supposed to be their longitudes. Okay, 25 degrees, okay, east and 95 degrees what? East, respectively. Okay, all right. So it means here, indirectly, if you are extracting, let's extract it the same form. Okay, given P, what is the latitude of P? 56 degrees. Okay, north. What is the longitude of P? We are told is this and this respectively, P and Q. So that will be 25 degrees east. Is my point well made?
Yes, please.
Okay, and your Q, okay, shares the same latitude, 56 degrees. Remember, it's latitude first, followed by the longitude. Okay, and the longitude, okay, of that your Q, we are told is 95, okay, degrees, okay, east. Okay, so this is what we have. Okay, so at this point, it's like, okay, instead of giving you this, okay, look at the way the question is put. So the other ones too, okay, I can put it in the same way. Okay, I can write only the common longitude or latitude here and state their, okay, other longitude or latitude, the different ones here, and I add respectively, that's all. So these are, I mean, the information. So in this case, what do? You go and draw, and you ask to find the distance, okay, PQ along the parallel of latitude. And if you draw, you will know that the PQ will be along, okay, a latitude, okay, which will be a small circle. Okay, and after that, you are asked to find the shortest distance, which will be the arc length. Sorry, the first one will be the arc length. The second one will be the chord length, okay, of PQ. Point well made, my professors. Is my point well made, my professors?
Yes, please.
Okay. Oh, our time, okay, I think it's even up. So let me equally chip in this. Okay, sometimes, okay, the question can give you, okay, the distance, okay, and give you the time that it took to cover that distance and ask you to find the speed. Okay, so in that case, you know you have to use that relation. Okay, speed is equal to what? Distance over time, is that not it? I hope you are with me. So if you are given the time and you will find the distance and you are asked to find, okay, the speed, it will be the distance that you have found, okay, divided by the time that you are given, and that will give you the speed. We can also, okay, ask you to find the distance between them, then give you the speed and ask you to find the time it took, okay, to reach what, to move from P to what, Q, to cover that distance. So that one too, you know what to do. Okay, it's the same, okay, question. Is my point well made?
Yes,
Yes,
Okay,
please.
so on that note, okay, this becomes your assignment. Okay, so this will be your assignment. I'll put it on the platform. And if you are able to do this, okay, I think this is similar to the one that the information that I provided is similar, only that here, okay, on the equator, so its latitude has been given, a special latitude. Okay, take notes. Okay, illustrate this and deal with it. Okay, so how far is we from the North Pole? If you are able to do that, this is 2024 WASI. Okay, the one that I told you. So let me see if you can make use of all that we've learned so far in dealing with it. I'll put it on the platform. Is that clear? And give you the deadline for the submission. Just try. Okay, and let me know where the issues are from your submission so that we address them. In that case, I will be more than convinced that anytime I see questions, okay, in the 2025 on the Earth as a sphere, okay, I know that, okay, anyone who was here under my voice, okay, that question, okay, I know you get the full score. So on this note, okay, thank you very much. Okay, God bless us all.